So, good afternoon, class. In the series of Fundamental of Maths, so far we had discussed about the various topics related to the you can say topics related to the mathematics. We had discussed about the coordinate geometry. We had discussed in the coordinate geometry regarding the equation of the circle, equation of the straight lines, and various type of equations which we had already deduced. It was in the form of y is equal to mx plus c. In that case, the m is denoted as the slope of the equation of the straight line, and c is the intercept made by that particular line on the x-axis or the y-axis. The y is equal to mx plus c. It means that m is the slope of the line and c is the intercept made by that particular line on the y-axis. And we had further elaborated some of the different form of the equation of the line based on y is equal to mx plus c. It was y minus y1 is equal to m into x minus x1. This is basically the two-point slope form in which we are having one coordinate of a particular point already given, and based on that we will be finding one equation of the straight line, and we had derived also some of the basic quantities related to the coordinate geometry. So we had discussed about the equation of the straight line, and in the part of the circle we had discussed about what is circle and what is the standard form of the equation of the circle. As we had already studied the and we are also knowing the definition of the circle. In that case, the circle it is a path traced by a particular point in such a way that path traced by a particular point. That means it is a locus of a particular point. Locus is the path traced by a particular point in such a way that its distance from the center is always fixed, and that fixed ratio, that fixed magnitude is termed as a radius of that particular circle. So we have already discussed about the locus of a particular point, the circle. The locus, the circle, whenever we are defining the circle, we are taking the help of a particular point, and from that point we are defining the point of the, or we are defining the circle. The circle, it is the path traced by a particular point in such a way that its distance from that particular point to the constant point is always fixed, and that particular that you can say that line segment, that particular constant line segment, it is defined as the ratio of that particular circle. Understood? So the thing is that we had defined about the equation of the circle in the standard form, in which x minus h the whole square plus y minus k the whole square is equal to a square. And the same thing which I had written on the board also, x minus h the whole square plus y minus k the whole square is equal to a square. In that case, we are seeing that h and k, this quantity h and this quantity k, these two quantities are defined as the center of the particular circle, and a is defined as the radius of that circle. So we had already seen the standard form of the equation of the circle, that is x minus h the whole square plus y minus k the whole square is equal to a square. So as of now, so today we will be discussing about the general form of the equation of the circle, which is taking the form of the standard equation of the circle only, but it is having the different nomenclature, and we will be seeing the proof of the same, how that particular equation represents the circle. So for representing the circle, the first and foremost condition will be there will be a center, the coordinates of the center will be given, first thing, and the second thing, the radius of that particular circle will be given. So from these two particular quantities, these two particular entities, we will be deriving the equation of the circle. So we will be saying the general equation of the circle. The general equation of the circle, it is taking the form of standard equation of the circle only, but it is having the different nomenclature, and we will be defining the general equation of the circle in this way: x square plus y square plus 2gx plus 2gx plus 2fy plus c is equal to 0. Now we will be seeing that how come that particular equation x square plus y square plus 2gx plus 2fy plus c is equal to 0 denotes is taking the form of the standard equation of the circle. So we will be deriving that particular point. First and foremost, we will be writing x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now this is the particular equation of the circle: x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now we will be taking the like terms together, the term which are containing x, we will be taking those terms together, and we will be taking the y terms together. So that will be x square plus 2gx, first and foremost, x square plus 2gx plus y square plus 2fy plus c is equal to 0. Now we are saying that we had taken the like terms together. We had taken the like terms together. The terms containing x at one place and the term containing y at another place. So we had got, now we will be elaborating this term x square plus 2gx in the form of a plus b the whole square. In this, for breaking this term into a plus b the whole square, we had already a square is there plus 2ab is there, but b is not there. So we will be writing b here, b square, and we will be subtracting the same quantity from the from that equation only, so that that particular transformation will not create any influence on the initial you can say equation. So we will be writing here x square plus 2gx plus g square plus y square plus 2fy plus f square plus c is equal to 0. Now we had added the quantities g square and f square so as to transform this particular equation in the form of a plus b the whole square. Now we will be subtracting the same quantity g square and f square from that particular equation only, so that our work will not create any kind of influence on that particular equation. So we will be writing here, it will be minus g square minus f square is equal to 0. Now we had got this particular equation, x square plus 2ab plus b square, a plus b the whole square is equal to a square plus b square plus 2ab. Now we will be writing here x plus g the whole square plus y plus f the whole square minus g square minus f square plus c is equal to 0. Understood? Now it is x plus g the whole square plus y plus f the whole square minus g square plus f square minus g square minus f square plus c is equal to 0. Now we have seen the standard form of the equation of the circle, x minus h the whole square plus y minus k the whole square is equal to a square. Now we will be comparing the equation 2 and equation 3, and we will be seeing that we can write here x minus of minus g the whole square plus y minus of minus f the whole square is equal to plus g square plus f square minus of z. Understood? So for that we will be under root squaring and we will be whole squaring that. So we had got the equation here in which the center is minus g minus f. The center is minus g and minus f, and the radius is under root g square plus f square minus c is equal to radius, and it is equal to the center of that particular circle. So we have got the equation in the form of x minus h the whole square plus y minus k the whole square is equal to a square. We had compared also the equation 2 and equation 3, and at last we had got the equation in the form of the standard form of the circle, in which the center is minus g and minus f, and the radius is under root g square plus f square minus of c. So this is the particular equation of the circle. So this is the standard equation of the circle which we had deduced. Now we will be further moving ahead of the same. I am just rubbing some part of the same. It is x minus h the whole square plus y minus k the whole square is equal to a square. For the definition of the circle, whenever we want to define circle, any geometric figure, it is the outcome of a locus of a particular point. So in the case of circle also, it is a kind of geometrical figure only. In that case, the path traced by a particular point in such a way that its distance from the constant point, that is center, is always fixed, and that fixed part is known as the radius of the particular circle. So this is the path traced by a particular point in such a way that its distance from this particular point or this particular point or this particular point, anywhere you can take from that center point, is always constant. That is radius. Understood? So we will be taking some, we had seen the equation of the circle in the standard form. We had defined the circle also. Now we will be seeing some of the numerical equation of the same part, that is, we will be seeing the numericals related with the general equation of the circle and the standard equation of the circle, which will render more transparency in our concept, and it will certify my statement also. We will be taking some more examples related to the same. Suppose in the given equation, the center is given. Center of a particular circuit is given 2 minus 3, and radius it is given, and it is the, and intersection it is given. Intersection it is 3x minus 2y minus 1 is equal to 0, and 4x plus y minus 27 is equal to 0. Suppose this is a particular equation. Suppose this is a particular equation which is given here. In this case, we have to find the equation of the circle in which the center of that particular circle is given 2, 3, and that particular circle, it is passing through the intersection of the two straight lines. So we are having the two conditions here. For the equation of the circle, we need two conditions. First and foremost, we do have one center of the circle, and secondly, we should have the radius. We should have known the radius. So we will be finding one extra point here, and from that point we will be elaborating. From that point we will be calculating the radius of that particular point. So we are using this equation: 3x minus 2y is equal to 1, and 4x plus y is equal to 27. Understood? So we are just multiplying this second equation by 2. So 3x minus 2y is equal to 1. 4 to the 8x plus 2y is equal to 54. So 11x is equal to 55. X is equal to 5. Now we have got x is equal to 5. Now we will be substituting back the value of x is equal to 5 in the equation number 1. So 3x minus 10 is equal to 1. Okay, 3x, sorry, 3, it is 3x minus 2y. It is 3x minus 2y is equal to 1. It is 3x. So 3 into 5, 15, minus 2y is equal to 1. 15 minus 1 is equal to 2y. 14 by 2 is equal to y. So y is equal to 7. So we had got a point 5, 7. We had got a point 5, 7, and we had the center here 2, 3. Now we will depict this particular form. We will depict this particular coordinate 5, 7 and 2, 3 in the form of a geometric figure. And it will be like this. It is a circle. The center is given 2, 3, and one point is given 5, 7, which is the outcome of the intersection of the two straight lines. So it will look like this only. Now from this particular point, we had got the two coordinates 2, 3 and 5, 7. Now we will be calculating the radius of a particular point. So radius will be under root x2 minus x1 the whole square. We had already studied the two form of the equation of the line in which we had already calculated the distance between the two coordinates. So we will be using the same concept here. So it will be 5 minus 2 the whole square, that is 9, plus 7 minus 3 the whole square, 4 square 16, that will be under root 25, that is 5. So we have got the radius is 5. So we had finally got the radius is equal to 5, and the center is given 2, 3. Now we will be using the standard form of the equation of the circle here. We will be using the standard form of the equation of the circle. We have got the two conditions here. First and foremost, we should have the center of the circle, and secondly, we should have known the radius. The radius we had already calculated, that is equal to 5. Now we will be using the standard form of the circle, x minus 2 the whole square plus y minus 3 the whole square is equal to 5 square. So this is the particular equation of the circle, x minus 2 the whole square plus y minus 3 the whole square is equal to 5 square, which we had got from the standard equation of the circle. So this is the particular equation. Now we will be seeing one more example. Suppose this is the question. This is a question pertaining to the standard equation of the circle. Now we will be showing one example which will be associated with the general equation of the circle. So we will be seeing that example also, which will render some kind of transparency and it will certify my statement also. Suppose we are in the question, it is asked to find the equation of the circle which is passing through the 3 points. In the question, suppose it is asked that we have to find the general equation of the circle in which there are 3 points are there and that circle is passing through these 3 points, and we have to calculate the equation of the circle. So we will be seeing one example. Suppose the points are 1 0 and the points are 1 0, minus 1 0 and 0 1. Understood? So in the question it is given that we have to find the general equation of the circle in which a particular circle is passing through these 3 points. So first and foremost, we will be writing the equation of the general equation of the circle: x square plus y square plus 2gx plus 2fy plus c is equal to 0. Understood? We had already derived this particular equation, that this is the equation which is taking the form of the standard equation of the circle, in which we are having the radius of we are having the center as minus g and minus f, and the radius is under root g square plus f square minus c. So first and foremost, these 3 points are given: 1 0, minus 1 0 and 0 1. We will be substituting simultaneously the values of x and y in the corresponding equation. So first and foremost, we will be taking the equation number 1. We will be substituting the value of x. It will be 1 plus 2g plus c is equal to 0. Post substitution, 1 plus 0 plus 2g plus 0 plus c is equal to 0. This is the first equation we had got. We will be entitling that equation as A. Now the second equation, in the second equation we are having the minus 1. So we will be substituting here minus 1, same result, y is 0 plus minus 2g, y is 0 plus c is equal to 0, that is B. So B will be 1 minus 2g plus c is equal to 0. So we had got the two equations, 1 minus 2g plus c is equal to 0 and 1 minus 2g plus c and 1 minus 2g minus c. So third equation is x is 0. So it will be 1 plus 2y plus c is equal to 0. Understood? No, it will be 1 plus y is 1. So it will be 1 plus 2f. 1 plus 2f plus c is equal to 0. That is equation C. Now we will be using the equation A, B and C in order to calculate the values of G and F. So we will be using the equation here A and B. A and B, so it will be 2 plus 2c. We had added both the equation. 2 plus 2c is equal to 0. So 2c is equal to minus 2, c is equal to minus 1. So we had got the value of c as minus 1. We will be substituting back the value of c in any of the equation. Let it be equation A or equation B, no matters, but we will be substituting that value in the equation. So we have got 1 minus 2g plus c is equal to 0. Post substitution, c is equal to minus 1. So 1 minus 1 it will be cancelled, g is equal to 0. Now we have got c is equal to minus 1, g is equal to 0. So g is equal to 0 and c is equal to minus 1. So we had got the equation here. So g is equal to 0. Now we will be substituting this value also. C is equal to minus 1. 1 minus 1. So f is equal to 0. F is equal to 0, g is equal to 0 and c is equal to minus 1. So we are having these 3 points here. G is equal to 0, f is equal to 0 and c is equal to minus 1. Now we will be substituting back that you can say these values in the equation number 1. So it will be x square plus y square, g is 0, y is 0, c is minus 1. So finally we are having the result here, x square plus y square and g is 0, f is 0 and c is minus 1. So this is the final result which we had got. The standard form of the you can say general form of the equation, x square plus y square minus 1 is equal to 0, in which that particular circle is passing through 3 points entitled as 1 0, minus 1 0 and 0 1. So this is the basic procedure related to, you can say, how we are finding the general equation of the circle from the standard equation of the circle. Now we will be seeing some of the properties of this particular point. First and foremost, we will be seeing the properties of the general equation of the circle. Properties. First property is this, that this particular equation x square plus y square plus 2gx plus 2fy plus c is equal to 0. It is quadratic in nature and it is dual quadratic. It is dual quadratic. That means it is quadratic in x as well as y. Here it is written, it is quadratic. It is quadratic in x as well as y. Both x square plus y square. Second property. The second property is that in this case we are having the coefficient of x and y. The product of xy is 0. Xy is not present in this equation. So we will be writing here the coefficient of xy is equal to 0. That is not present in the equation. The third point denotes that the coefficient of, you can say, the coefficient of x square, the coefficient of x square is equal to coefficient of y square. So we have the three properties here. First and foremost, it is quadratic in x as well as y. It is quadratic in x as well as y. Secondly, the coefficient of xy, the term containing the product of xy is not present in this equation. So we can write here coefficient of xy is equal to 0. The third condition is the coefficient of x square is equal to coefficient of y square. So these three are the properties of the general equation of the circle. Now we will be seeing some of the important here. And fourth property is that in this equation x square plus 2y square plus 2gx plus 2fy plus c, we are having three arbitrary constant. Those arbitrary constant are g, f and c. These three are the arbitrary constants in this particular equation of the circle. So we will be saying some more examples which will render more transparency in the concept, and it will be helpful for us also. These some of the concepts are here. Suppose we are having any equation of the circle. Equation of the circle, if it touches the y-axis, if it touches the x-axis, if touches x-axis. So this will be the figure if it touches the x-axis. So in this case, any particular point will be there. Suppose we are having the center here 3 4 and we are having the center of the circle as 3 4 and this particular circle is touching the x-axis. So in this case it will be 3 and the y coordinate will be 0. If any circle touches the x-axis, in that case the y coordinate will be 0 and the x coordinate will be as it is. So we will be writing the equation here. Now we will be using the distance formula to calculate the radius. It will be under root x2 minus x1 the whole square plus y2 minus y1 the whole square. It will be under root 16 4. So we are using the equation x minus 3 the whole square plus y minus 4 the whole square is equal to 4 square. So we have got the equation x minus 3 the whole square plus y minus 4 the whole square is equal to 4 square. So this is a particular equation of the circle which is having the center as 3 4 and it touches the x-axis. Whenever any circle touches the x-axis, in that case the y coordinate will be automatically 0. That is the concept, that is the underlying concept in this. So we had seen some of the examples related to the general equation of the circle. We had deduced also the general equation of the circle, how it is taking the form of the standard equation of the circle. We had seen the properties of the general equation of the circle. Moreover, we had came across some of the numericals, some of the concepts which will render more transparency while we will be solving some more complex numerical problems. So this is all about today. We had studied about the general equation of the circle. Now in the next class, we will be moving to different form of the equation of the circle. I request my viewers so as to see my video. If any doubt is there, please do comment in the comment box so that I will be seeing that queries and I will try to resolve that particular queries within the stipulated time. Thank you.